Sure, thanks. Thanks for being here. Thanks for having me here. Kind of last minute things. Happy to help Luis out. It was great. He gave a presentation up at the Austin BIM Peer Group. Was it 3 months ago already?
I think it was 2. Yeah.
2 months ago?
Yeah.
So talked about the Texas A&M projects. It was really good. We had a discussion about some of the things I could talk about. There are a number of things, and we settled on was kind of an introduction to the Nemetschek Group. What we do, who are we as a company? Have you heard the brand? You know, what do we do? What are our products? And what does it mean to the AC world? So, Nemetschek as a brand is most known in Europe. It was originally established this year is the 50th year anniversary. Georg Nemetschek. It started as an engineering firm, created their own software solutions for their own engineering company, and then began to roll out those software solutions out into the marketplace. So it's a company that's been around for a while. It has evolved. It's evolved now into a company with over 1,200 employees in 15 countries. However, we're talking about over 300,000 customers in 142 countries and 11 product lines. So think of Nemetschek AG as not unlike Bentley Group or the way Autodesk operates, where there's a number of technologies and opportunities out there that we kind of bring under the brand umbrella. For us, though, in the U.S., there's really 5 major ones that are present. The technology really covers things from architecture to engineering, different types of engineering, to management and multimedia. We have Nemetschek SIA, which is our engineering, main engineering platform. Frelo and Glazer are also engineering tools that interface with SIA and Allplan engineering, but they're primarily we call DACH country, DACH market, Deutschland, Austria, and Switzerland. And same with Auer and Bausoft and Creme, which is a facility management software. But you'll see SIA, and then of course, if you're familiar with Archicad by Graphisoft, and ourselves, the company that I work for, Nemetschek Vectorworks, based in Columbia, Maryland. We are the only U.S.-based company within the Nemetschek Group. And then, how many of you heard of Cinema 4D? That's Maxon. That's also a Nemetschek company. And they're very well integrated into the group, as we'll see. So the first one I'd like to talk about is a new one. It's actually called BIM Plus. It's a new platform that was introduced in January at one of the largest construction shows in Europe. It happens in Germany, Berlin, every 2 years, I believe. And what it is, it's a project collaboration platform. It's similar to Buzzsaw, similar to ProjectWise, but it's also, say, a combination of those with G-Team. Are you familiar with G-Team? It's a product by Gary Technologies. It's a large cloud-based model collaboration project coordination platform where you essentially, it doesn't matter what application that you're using, you upload your models up into their cloud for your project cloud, and all those models can be then viewed in the same space. You can do versioning, you can view the version of an architectural model from 1 week with an engineering model from another week. You can swap those out, you can go backwards, forwards, do backups, do communications, project communications, and all that. And so with BIM Plus, essentially you have a large cloud-based database, right? You upload models, you upload documents, photos, everything that's related to the project, and it all becomes linked and coordinated. And the great thing about BIM Plus is, and what Nemetschek is pushing, is what they call All Connect. Any app, any platform, any model, any device, anytime, right? All the APIs are going to be totally open. You can use any modeling tool, and you'll be able to use any device. So right now there's about 6 mobile apps that they're working on, primarily geared in the European market. Eventually those will be rolled out internationally. And they are things like viewers, model viewers of the models that are uploaded in the cloud. There will be note-taking, photos, and markups, type of field tools that many other vendors have available today. And of course, devices, both desktop and tablet, mobile devices. So, and when I say it's open too, there's a large component of it that is based on IFC, but also that the APIs are open in a sense that you'll be able to suck up the information. It stores it in its own database. And the idea is that it will allow developers to come in and develop their own applications on top of that database. So if someone has a great idea for doing say a project management application for the data platform based on BIM Plus, they're allowed to come in, they're given access to the SDK, and they can develop their own application, and then we put it in the BIM Plus store, and people are allowed to buy it. If you're familiar, Archicad by Graphisoft, an architectural BIM package. It is one of our sister companies, or as my boss likes to say, we purchased them in 2006. Their modules include Eco-Designer, MEP Modeler. They have a viewer, BIMX, so that you can view the Archicad files on both desktops and on mobile devices. Of course, their BIM server, and then their Start Edition. Cinema 4D by Maxon. Really, they're the premier rendering package that we see as a global premier rendering package. It includes everything from architecture to engineering. When it comes to movies and television shows, you see their work all over the place. Anybody go see Prometheus? Mm-hmm. Yeah, that's a big one. But there's been a lot of films. And then the architectural rendering, they've really made a lot of headway in the last 10 years in architectural rendering, the way that their product is set up and the modules that they've set up. And now even in Vectorworks, starting 2 versions ago, we actually use Cinema 4D as our internal rendering engine. So most of what you can do in Cinema 4D as a standalone package outside of animation, you can do inside of Vectorworks now with RenderWorks. And then also a lot of scientific, if you watch Discovery Channel or Health Channel or Nova, there's a lot of those animations and renderings that happen with the help of Cinema 4D. C Engineer, as I mentioned before, structural engineering BIM platform, modeling, but also analysis and design and documentation. So within SIA Engineer itself, you do all of that. It has all of the analytics built into it. And it is used in a wide variety of applications, from buildings all the way through industrial processes, even large complex scaffolding construction for high-rises and large projects. It's very well known for its ability to handle multiple materials on very large projects. So it can do steel, concrete, and wood all in one structure. It doesn't need to be split up and done by different programs. It's all done within the SIA environment. And then it has great collaboration interoperability capabilities. So they do have a plugin for Revit, but they also have the ability through IFC to receive and exchange models through a number of different platforms. And then finally, Vectorworks, the company that I work for, based in Columbia, Maryland, available both on the Mac and PC. We like to think of ourselves as tools for designers. Not just architects, but designers of many kinds. Our platform essentially includes Architect, which is our main CAD and BIM platform, Landmark for landscape and architecture and landscape design, Spotlight for theatrical and entertainment design, a lot of the TV shows, TV sets, movies that you can think of, the new James Bond films, you've seen those? Sets designed using Vectorworks. The lighting setups for a lot of major concerts have been done by designers who use Vectorworks to do all of the documentation and modeling, and then they'll even do pre-visualization, and then they'll do advanced visualization in Lightworks. And then Designer kind of wraps them all up together, and RenderWorks is our, as I said before, our rendering package which uses Cinema 4D to do renderings. And then we also provide Vectorworks Cloud Services, which is for our Service Select customers, it's our subscription customers. It allows them to have a cloud solution where they can take their Vectorworks files, instead of rendering them on their desktop, they're rendered up in the cloud and then produce PDFs automatically for them. And then from those cloud accounts, they can begin to share that information with customers. There's also Nomad, which is the iOS and now Android application that allows you to view those files and do markups in the field. So, what does BIM look like from the Nemetschek perspective? I think because of the type of setup, because of the type of company that Nemetschek is, Nemetschek AG is, and all of us operate independently, there's a understanding that BIM is a very large and complex process that is served by technology, right? And there are so many things that can possibly go on in the BIM process. So many points where high-value processes can occur by many different types of people. And that it's impossible really for one person, one company, one technology to do it all, right? It's impossible to do. It's just too large. So instead, there's an idea of focusing on this idea of trying to create the best-in-class solutions where they can, and then finding the opportunities to collaborate with the rest of the BIM community. So if we look at the BIM software market, right, we're talking about an industry that's over, I think the latest numbers are 7.4 trillion in the global construction industry, and 5% of that is spent on software. Okay? But within that market, you look at it, as big as Autodesk is, there's still only 1/3 of all the software that is sold globally to get this work done. Okay? So when you look at the diversity involved, how do you move forward? Right? How do we get BIM to work for everybody without everybody being required to buy the same software or work on the same platform? Everybody has all of these technologies, some very good technologies that do very good things. Some of the technologies work for very specialized reasons and specialized processes, right? And it's very difficult for those things to kind of be a jack of all trades, you know, and end up being a master of none, right? So wouldn't it be better instead to have these type of communication, these type of collaboration where everybody can work together and still have their best-in-class tools? And, you know, we're used to digital interoperability, right? I mean, think of all the different pieces of mobile hardware we have available to us today, whether it's, you know, iPhones or Windows phones, which few they're still left off, you know, they're left off. Blackberries, Android phones, tablets, desktops, laptops. I mean, we're all able to communicate. All that information that is on the internet today is available to everybody because of open standard protocols, right? Because they were able to connect all that information together by agreeing on certain standards in the way to encode and distribute and display that information. So, how many of you ever heard the concept of Open BIM? Right. Now, this is a specific trademark, and this specific trademark is referring to interoperability using industry foundation classes, IFC, right? And this trademark was formed by a consortium of companies, along with Building Smart International. They're the group that is responsible for the creation, the maintenance, and the distribution or education of IFC as a product, right? As a basis or as a platform for BIM to happen, for communication of BIM to happen. I like to tell people that IFC is to BIM like HTML is to the internet. You know, it doesn't do everything. It doesn't do the calculations. It doesn't do the creation itself, but it is a means of communicating all of those things that were created at one point or another and passing that information along to somebody else and stored somewhere. You can make use of the information only if you can have access to it. So what IFC does is it provides that access from wherever point to whatever other point. And this consortium is growing and is eventually going to include even Autodesk. The negotiations are going underway right now. So what does this say? It means Autodesk, in the work that they've done recently in supporting IFC with 94 other vendors and 144 other applications around the world, support IFC. And right now, there are 20 vendors, 25 applications that are part of what we call IFC Certification 2.0. What does that mean? Well, the certification process is a means to guarantee to the public, guarantee to the end users, that there is a minimum quality standard for the exchange of this information. That no matter what application you start with, when I export an IFC model, you'll know that it is a perfectly capable, technically correct IFC model. And that if you have an application that's certified for import, you'll be able to read it. And if you can't, it's not because of the application. It's because the user on one end or the other has probably done something wrong. An improper setting, missing information. As I tell people, you can take any piece of software from any of these competitors and you can make a really cool model. And it's a crummy BIM, right? With a little more effort, a little more training, you can go from a really cool model to a good BIM and cool model. And with a little more effort and training, you can even turn it into a good interoperable BIM, right? Something that you can actually share and use in more than just, beyond your office walls. But that does take effort. It does take knowledge by the user. What we're trying to do is remove the uncertainty from the technical side of things through this certification. And right now, we have a number of applications that are already certified. So Autodesk has Revit Architecture and Revit Structural. Revit MEP, I'm told right now, is very, very close to being finished. Graphisoft, Archicad, Allplan, Vectorworks, and C Engineer are all certified for export right now. So 2 for structural and 3 for 4 for architectural, and there's more coming. That's a pretty big commitment to IFC. And one of the ways that we like to show our commitment to IFC in the Nemetschek Group is by highlighting the opportunities or the ways that these open BIM can work, that IFC-based workflows can work. So I'm just going to show you just a quick example of one from the Nemetschek Vectorworks perspective. Graphisoft people have them. There are numerous examples from other groups in Europe. In fact, really the push for IFC is a European push. A large part of it is political and cultural, but you'll see in places like Finland, and Norway, where IFC there's a really big push. There's a lot of projects that are being done today where the platform is considered to be IFC, not a vendor's platform, but that communication platform is the standard. So in this case, we're working with other Nemetschek Group partners, so SIA, and in this case, we're also working with Celebri. And how many of you are familiar with Celebri? They're a great tool. I tell everybody that should be the one other BIM tool you should have. It's a must. It's a go-to. And it does an excellent job of consuming a model file, specifically IFC, but what you're able to do in terms of data mining, in terms of quality assurance and quality control, collision detection, just finding out what is in the model, what is there, where is it, how much of it is there. It's an amazing tool, and really, frankly, I think one of the easier ones to use. IES, are you familiar with Integrated Environmental Solutions? So they are really the largest European building energy performance simulation and analysis software out there. All right. They've recently made some very big strides in the global market. It's in the last 5 years. We've been cooperating with them for the last 2 years. They're now a strategic partner of ours, and what you'll soon see is some closer collaboration. We're working in an IFC communications so that we can send our models from Vectorworks directly to IES through IFC. And their IFC development is really only 18 months old, and they've come a long way. And they see it as the future too. But it's a really incredible tool, and we'll see some screenshots of what it's able to do. Synchro. Synchro is another construction management software. Construction logistics, timing. And it's a web-based solution. They also have a desktop component, I believe, too. But they also will suck up IFC files and process IFC files. And then Data Design System. They make a product called DDS CAD. Primarily Norwegian, also German-speaking, and then they're pushing into Brazil right now, too. I want to talk about the largest or fastest growing construction market in the world. It's Brazil. Not China anymore. China's on the downside. Russia's trying, but Brazil is the hot spot right now. Everybody's scrambling to do something in Brazil. So we worked with DDS on a test project in Brazil. One of the largest construction companies in Brazil, Capisa, was looking to automate their construction estimation and tracking and essentially dive into BIM. And they were looking for how they were going to do this. So it was essentially an open competition setup, and all the vendors teamed up. So we teamed up with DDS, Archicad teamed up with DDS, we teamed up with SIA and Tekla and others. Autodesk was represented and Bentley was represented. And essentially we were all given the same building, and they said, okay, model this and tell us how much stuff there's in it. We already know because we've already built this building, but show us how we can do it. It's been an incredible process, and it's opened us up to a brand new market and a lot of new potential customers. So one example is just a project in the Dominican Republic. It's called Ouellette. It's a multi-story residential project, and essentially you start with Vectorworks Architect, doing some general programmatic studies and massing studies, and then moving into using BIM elements. And being a large building has multiple components. There's the base, which is parking, and then you have some common utilities. Then you have the residential units, penthouse area, and then this exterior skin. And the exterior skin is interesting. It's half decorative, half solar shading skin. So it doesn't do 100% solar shading for all of the units, but it's an interesting design concept. And so all of this was actually modeled in Vectorworks, and then it was chopped up into pieces, and then it was actually milled pieces that I think the largest ones were 8 feet tall and sectioned off, and then it was assembled on site. So it's all EVIS, polystyrene kind of stuff with the shiny finish on it. But that's what it looks like. So going from a Vectorworks model and exporting it out to IFC, being able to capture essentially all of the geometric information is just one step, but it's a major step, right? I can get out of my native platform and I can push it out so that it can be used by other applications to get their work done. So using IFC as a means to do quality control, quality assurance that the model is correct. It's very easy when you're kind of sitting there and modeling and trying to put this design together. It's very easy to make mistakes, right? The software is smart, but the software is not, omnipotent. It doesn't really know everything. It allows you to make mistakes. And the great thing about tools like Sleep or even Navisworks is it'll find the mistakes for you, right? It understands the rules and relationships between objects. So you're able to send this model out and you can see, hey, these walls were too tall. They intersect with these beams. Excuse me. Or that I don't have certain clearances here in front of certain doors in my unit. So I can use this as a quality check even for my use as an architect in Vectorworks, right? And do the same thing. Solibri likes to talk about this in terms of using Revit too. Is how do I know I've got a good model, right? I have to do a quality check. How do I do that quality or sanity check? So then taking that model once it's finished and pushing it out for building energy performance. As I talked before, is using IES. IES is an interesting company. They sell software, but they're also a consultancy, right? So they have a number of scientists and environmental engineering experts that not only are responsible for creating the software, but they're also responsible for training people to use the software. And when it's too big of a project or too complex of a project for an engineer or an architect or somebody to handle, they'll do the work themselves, right? And they're based in Glasgow, Scotland. So we do a sanity check and we say, okay, what does Solibri need? Well, Solibri wants shading devices and spaces. That's it. That's how they do their simulation. Because all of the information, the thermal information from walls, all of the thermal characteristics of a room, the requirements, it's all encapsulated in the space objects. It doesn't need all of the walls. It doesn't need all the junctions. It doesn't need all the doors and windows. What it needs are the spaces and what we call space boundaries, right? The hole that represents where the window or where the door is. That's all it cares about, these planes. And once you transfer that information out, it's able to create these analytical models. And from those analytical models, its algorithms are able to produce the information that is crucial to understanding the building's performance, right? So just roughly see here is, you understand what's happening with wind on the building, from where the prevailing winds are, and where the turbulence is happening there. There's a larger color picture of it. You can have solar studies and what's happening of all the surfaces subdivided in terms of heating throughout the day, different points of time, right, in different times of the year. And then producing the psychometric charts. What's happening in terms of the comfort level to the spaces inside of the building based on the climatic data for this particular location, right? And even looking here is a detail of what effect does the winds and the orientation of the building have on the balconies. Is there a positive pressure? Is there a negative pressure going on there? People going to basically get sucked off their balconies every time they step out there. So it can provide that type of information, and that's great. Taking that same model and moving it over to Nemetschek SIA. The Nemetschek SIA is basically sucking in that IFC model and then going through a transformation process where it says, okay, I have this IFC model, I understand here's a beam, I understand here's a slab, but I have to turn that physical model into an analytical model, right? Because the analytical elements are different than the physical elements. When I have a slab, it has an analytical plane. What is my plane? What is my diaphragm? How do I, and then for a beam, is it the center line of the beam? Is it the edge of the beam? Well, the structural engineer knows that, not the architect. And the structural engineering software is intelligent enough to help the structural engineer make those determinations and clean up all those intersections. Because as an architect, we think a lot about the physical details of the way a building goes together. But what the structural engineer needs to do in the analysis and design is figure out, well, where are the forces meeting? Where are they actually coming together? And how does that actually work? And then from CA, you can even take it over to Tekla, where it says, okay, well, I know in principle how all those things are happening, but then when it comes time to detailing it, how do I do that? And an application like Tekla is very useful because then you can actually take those pieces and put them together all the way down to the bolts and the rivets and the welds. So here you see the basic frame, concrete frame, you see the plate elements, how everything goes together, and they start doing structural analyses on the analysis model, right? The abstract model, where you see where the stresses are on the plates and in the walls, these nodes. Then you take that information and you actually are able to overlay it simultaneously with the physical structures. So you can then begin to see what happens to the deflection of the slab within the skeletal frame, right? What's happening with the pressures on that? And where is more structural reinforcement going to be needed? Or is more a thicker slab needed? Or is more structural framing going to be needed? At the same time, mechanical electrical engineers can be working. And in this case, we were working with engineers from DDS-CAD. And they were able to take that same IFC model, that same base model that we gave to the IES guys, that we gave to the SIA guys, and they were able to suck it in and start laying out the HVAC and plumbing work for each of the stories, for each of the units. Right? And this is just a snapshot of their tool. And then they're able to export that out as IFC models. And we're able to combine all those models in places like Celebri, right? Where we can take the architectural model and the structural model, and then the HVAC and the plumbing, and put it all together and see how it works. Take sections of the building, take lives, drag the little cutting plane through there and begin to see what's happening. And then run the rule checking. Show me my clashes, right? Show me my clashes between architectural and structural, show me my clashes between structural and MEP, show me these and make a list of them. And even then taking all of that information back and sucking it back into Vectorworks, right? Because what's important for the architect is not only giving the information out for all the design partners to use and react, but then getting all of those models back so that the architect can make adjustments. So essentially, what the structural engineer was able to create and what the MEP engineer was able to create is then brought back via IFC back into Vectorworks and overlaid with the Vectorworks internal data model, right? And all displayed in the same place. Then I can begin to see where I need to make those adjustments. Now, ideally, I'm still going to produce those reports, those clash detections, where the problems are in Celebri, and then I'll distribute those reports out to everybody and say, hey, we have to make our changes, right? So here's where we make them, here are the highlights, and now I can go back as the architect and I can make those changes. But then I can also begin to pull together these type of presentations and do this type of coordination even inside of Vectorworks. And then using a tool like Celebri, as I said before, probably the one tool I said everybody has to have in their BIM toolbox. Why? An example, spatial program validation. So this is what the GSA uses as a part of their mission as the world's largest landlord, right? Hundreds of millions of square feet. Hundreds of millions of square feet of office space they have to manage. 100 million square feet come on board every 2 years. That's a lot of space. So what they're responsible for is, what are the spaces, how big are they, who's in them, and how much are they paying for them? And then when somebody moves, they have to track all that. That's all been done by hand for decades. What they do now is they use Celebri as a tool in order to aggregate all the information. All they really care about are the spaces. They have general information about the structure of the building, walls and windows and door locations and all that. But what they really care about are these spaces. And the spaces are tagged with information, right? Within the BIM model, it knows what building it's in, it knows its site, it knows what story it's on, it knows what its room name is, but they're also to add information like which department does it belong to? And what's the sub-department? What's, that it belongs to within that overall department? Sure, it says, DOD, but where within the DOD? And then who's responsible for it? And then who's the person that's in it? And how much space is in there and what's their lease rate? Because ultimately, every agency needs to know that as part of the budgeting process. And what the GSA does is they create these lists, and the original lists are all in Excel, and those lists are then compared within Celebri against what the model says. And if they don't match up on a design, they can say, hey, you were told that this department needed, 200 square feet per office, and 50 of the offices are under 150 square feet. We found that out by just looking at the model. So what are you going to do about that? Or if it's over, or if it's, how close is it? And then they're able to track all of that information. Quantity takeoff. So within BIM, I can start adding information to physical objects, right? For these, the analogies to physical objects. And what kind of wall is it? Is it an interior wall? Is it an exterior wall? What kind of interior wall? Is it a firewall? Is it a roof slab? Is it an intermediate floor slab? I can add all of that category information based on uniformat, based on master format, based on any type of classification. Omni-class, however you want to put it together. And I can begin doing information takeoff within Calibre that says, hey, show me what I got. Group it together, color code it for me so I can see what's going on. Right? That's where really the power of BIM is. You know, the modeling can only take you so far. You know, putting the information in can only take you so far. But if you can't do something with it after it's all in there, then what good is it really? Right? I want to take it to the next level. That's where the value is in. And not just for the construction process, but then this becomes valuable for the owner too, right? Because now you have facility management software that is able, CMM and even CMMS systems that are able to suck up IFC models and begin to develop their information through things like Kogi or through IFC directly. So example of Synchro, this construction management, project management software. And Synchro we've been working with, it's been 2 years now. And what they do is they take this IFC model and they're able to assign time attributes to all of the pieces. So they can do it on a floor basis or they can do it on an element basis. So one of the first experiments they did with this building is they did it just kind of floor by floor. But we all know you wouldn't build a building truly floor by floor. I mean, this is a concrete cast-in-place structure. So, you know, the structure is going to go up floor by floor and then things are going to get filled in behind it. But the interesting part was all they had to do was be able to identify the elements. And then they can add that information in. They didn't have to go back to the architect and say, hey, architect, you need to fill this out before you give it to me. No. You gave us the physical model. You gave us the data, the base data that's already there. We know what everything is named. We know what everything is in. Now we can add our data to it, and we can manipulate it and use it and move forward in the process, and then do a timeline of how long it would take to build this building, all the pieces, and go back and forth. I mean, this is the thing that everybody's looking for, right? And the reason that Nemetschek